Guys, welcome back to our YouTube channel. Today we're going to be solving this simple math equation where it asks us to find the value of x in this equation. We're just going to dive straight in and start solving the equation to see how we can do it. So looking at it, we're going to first start by rewriting the equation with common basis. The first and most powerful strategy for exponential equations like this is to rewrite the numbers as power of their prime factors. This helps us find the common terms we can work with. The number 8 is equal to 2 times 2 times 2, which is equal to 2 to the power 3. This implies our 8 to the power x is equal to 2 to the power 3, or this to the power x, which is simply equal to 2 to the power 3x. The number 6, looking at this now, 6 is simply equal to 2 times 3. This implies our 6 to the power x is equal to 2 times 3, or this to the power x, which simply is equal to 2 to the power x times 3 to the power x. Now, if we substitute this back in the equation, which the equation is going to give us now 2 to the power 3x minus 2 to the power x, all this divided by 2 to the power x times 3 to the power x minus 3 to the power x is equal to 2. This really looks much more manageable because we can see the term 2 to the power x and 3 to the power x appearing in multiple places. So we're going to do by factoring out the numerator and denominator. Now we can use algebra to simplify the fraction. We'll factor out the greatest common factor from the top and bottom. So we are going to start with the numerator, which gives us 2 to the power 3x minus 2 to the power x. The common factor here is 2 to the power x. So we're going to factor it out, which simply implies, which for me gives us 2 to the power x in bracket 2 to the power 2x minus 1. Now let's do same for the denominator, which the denominator is going to give us 2 to the power x times 3 to the power x minus 3 to the power x. Now the common factor here is 3 to the power x. So if we factor it out, it's going to give us now 3 to the power x is in bracket 2 to the power x minus 1. So from here, our equation now is going to look like this: 2 to the power x in bracket 2 to the power 2x minus 1, or this divided by 3 to the power x in bracket 2 to the power x minus 1 is equal to 2. We can simplify this even more. You notice that if you look at it very well, you're going to notice the term 2 to the power 2x minus 1, which implies this is a classic algebra pattern called the difference of squares. And the difference of square gives us a pattern where a to the power 2 minus b to the power 2 is simply equal to a minus b in bracket a plus b. And if you look at this equation, this very well, you're going to see now that our a is equal to 2 to the power x and our b is equal to 1. So 2 to the power 2x minus 1 is simply equal to 2 to the power x, or this square, minus 1 square, where our 1 square is basically equal to still 1, which this will simply imply from this is going to give us now 2 to the power x minus 1, or this in bracket times 2 to the power x plus 1. Now, if we look at it, we're gonna substitute this in our equation now. So we're substituting it now, which our equation now gives us what? 2 to the power x in bracket 2 to the power x minus 1 bracket 2 to the power x plus 1. This looks simple, right? Divided by 3 to the power x in bracket 2 to the power x minus 1. All this is equal to 2. This is our new equation. Now, if we look at this equation very well, we're dealing now with potential, which is basically a trap. Now, extraneous solutions, we see that 2 to the power x minus 1 is a term on both the top and the bottom, which is great because we can cancel them. However, we must first be sure that this term is not equal to 0, as division by 0 is undefined. So let's check what happens if 2 to the power x minus 1 is equal to 0. This implies our 2 to the power x is equal to 1. This is only true. This equation, when x is equal to 0. Now we must test if x equal to 0 is a valid solution in our original equation. So let's just quickly substitute it, which gives us our 8 to the power 0 minus 2 to the power 0, all this divided by 6 to the power 0 minus 3 to the power 0 is equal to, if you look at it, anything to the power 0 is 1. 1 minus 1 divided by 1 minus 1 is equal to 0 divided by 0, which this, according to math, is undefined. Now, because it is undefined, it's an extraneous solution that we must discard, since we've proven that x cannot be equal to 0. We know that 2 to the power x minus 1 is not equal to 0. So you can simply and safely cancel it out. Now, we're going to cancel it out. Now, solving the simplified equation after cancelling the common terms, we are now left with a much friendlier equation, which is a fraction of 2 to the power x in bracket 2 to the power x plus 1, or this divided by 3 to the power x should be equal to 2. Simply because you can remember from here, we cancelled this with this. Now, because we cancelled this, we're left with this equation. Now, we are going to multiply both sides with 3 to the power x, which gives us 2 to the power x bracket 2 to the power x plus 1, all this divided by 3 to the power x times 3 to the power x is equal to 2 times 3 to the power x. This cancels this, giving us a final equation of 2 to the power x in bracket 2 to the power x plus 1 is equal to 2 times 3 to the power x. Now we can simply expatiate the equation, and this is how it's going to be: 2 to the power x times 2 to the power x plus 2 to the power x is equal to 2 times 3 to the power x. So I've opened the bracket, which gives us 4 to the power x 2x. We're going to erase this, which gives us 4 to the power x plus 2 to the power x, which is equal to 2 times 3 to the power x. Now we're going to continue solving this. So looking at it now, we're going to divide each term with 3 to the power x, which gives us 4 to the power x divided by 3 to the power x plus 2 to the power x divided by 3 to the power x is equal to 2 times 3 to the power x divided by 3 to the power x. This will cancel, which is simply giving us 4 divided by 3, or this to the power x, plus 2 divided by 3, all this to the power x should be equal to 2. So at this stage where we are right now, the equation is best solved by inspection. Let's test a simple common value for x. Let's test if x is equal to 1. What does our fraction become? It becomes 4 divided by 3 plus 2 divided by 3, all this to the power 1. And when you add it, it gives us 2. This is correct. That means the equation holds when x is equal to 1. To be certain it's the only solution, consider the two terms on the fraction. On the fraction, 4 divided by 3 to the power x is an exponential growth. Since the base is greater than 1, as x increases, these terms get larger. The fraction 2 divided by 3 to the power x is an exponential decay term, since the base is less than 1. As x increases, these terms get smaller. The combination of these two functions results in a curve that can only be equal to 2 at one valid point. The other point being the extraneous solution where we tested out where x is equal to 0 can be ruled out. Thus, we can be confident that x is equal to 1 in the unique and correct solution. So looking at it, we have finally found out that what? Our x is equal to 1 and can only be equal to 1. Thank you for watching this video. See you in the next video.